Okay, so welcome back, and thanks for coming, Marina, and Roxy, and Maddie, and Denise, and Sophia, Marquette, and Lou, and Jack, and Nate, and Jacqueline. So let me share my desktop, and we'll do the quiz. And as my warning was a couple days ago, is it does make you think. So let's start thinking. So let's do the quiz, and let's get to it. Okay, so here's your quiz. And question 1. A password contains 4 digits from 0 to 9. Okay. It shuts down to the user after 5 unsuccessful attempts. Okay. Be sure to show your work. If the digits cannot be repeated and a hacker tries to hack in using random attempts, what is the probability the hacker will get in? Okay. So there's a probability question. And what I did, because I find it at least easier for me, is I copy and paste it right into the answer area. And that way I don't have to go back and forth on the answer. It just makes it a little easier. So let's take a look at the probability that a hacker gets the number. Okay. So let's write probability. It's always good to write P for probability. And the probability of, let's call it hack. Okay, first thing is probabilities of fractions. How many different combinations make it so that the hacker gets it? It's a very easy answer, by the way. Or pretty easy. One, except how many times does the hacker try? 5. Do you see? So the hacker's going to try 5 different combinations and hope to get in. Does that make sense? So the numerator is 5. So that was supposed to be easy, but again, you have to read the question. Okay, now comes the next part. If the digits can't be repeated, so that means the hacker is going to pick numbers 4 different numbers from 0 to 9. Does that make sense to everyone? How do we find out how many ways there are of picking 4 different numbers from 0 to 9? Do you remember how to do that? It's very similar to something I did 2 days ago.
You put it as fractions and multiply it?
Here's a hint. Look what I put in the question.
Combinations and permutations?
Yeah. So the easiest here is hit combinations and permutations. And we have 0 to 9. There's 10 numbers from 0 to 9. The hacker is going to pick 4 of them. And here, order does matter. So that means it's a PNR. And that's it. Okay. Yes, it's 10, 9, 8, 7, but this is a lot faster. So that's why I let you have the calculator for it. Okay. So it's 50-40.
Wait, how do you wait, go back up. Go back up to the calculator. How do you determine if it's CNR or PNR?
Okay, so CNR is when order doesn't matter. So if your password is, 1, 2, 3, 4, and the hacker does 4, 3, 2, 1, the hacker's not getting in, right?
Yeah.
Okay, so order matters. So PNR is when order matters. CNR is when order doesn't matter. Okay, CNR was for like the poker game because it doesn't matter what order you get the cards. A flush is a flush. Does that make sense? Or a straight is a straight. PNR is when it doesn't. Okay. Now, if you did 10, 9, 8, 7, you'll get the same answer. What does N and R stand for? N is the number of items in your that you're picking from, and R is the number of items you're picking. Okay, so in this case, you're picking from 10 and you're picking 4 items. or 4 numbers. So 50, 40. And now I just go down a bit. 5 over 50, 40. Okay, and that's good enough. Okay, we got a probability. As I mentioned, for quizzes, you're not responsible for like getting decimals to some number of digits or anything like that. For your homework, you do whatever it asks you to do. Sometimes it says, write it to 4 decimal places, but for the quiz, you don't have much time, so that's it. Any questions on that? Okay, so now if the digits can be repeated and a hacker tries to hack in using random attempts, what is the probability the hacker will get in? So now it's still probability of hack, but the rules are different. So now we can repeat. So what's the probability the hacker is going to get the first one correct? The first digit correct?
1 out of 10.
Yeah, so it's 1 over 10. What's the probability for the second one correct?
1 out of 10. So
exactly. So, and they're going to try 5 times. So it's just going to be 1 over 10
0.01%.
to the 5th power. Okay. And if you stick it in a calculator, or if you could just leave it like that, I'll be okay. Actually, you should have parentheses. It's never open and not close. But this one, actually, you don't need a calculator for, because 1/10 to the 5th means that you're going to have the 1 5 decimals away. So 0.1, 2, 3, 4, and a 1. Any questions on that? Any questions on question 1? Am I right that it's easy to watch? Why isn't the same done the first one? The main thing is, see this word cannot versus this word can, that makes a big difference. So if it can't be repeated, that means we're talking about permutations. We're talking about, 1/10, 1/9, 1/8, and then 1/7 and 1/6.
Mine raised to the 5th.
What's that?
For some reason, I had mine raised to the 4th.
Oh, sorry, it is 4th. It's 4th.
Oh, okay.
And we should multiply that by 5. So I hadn't finished yet. So multiply by 5 because you're still getting 5 attempts.
Oh, okay.
Okay. And that is 5 over 10,000. There's lots of ways of writing it. This is a decimal way. Okay, should we do question 2? Okay, at a gym, 60% of those who come in start on the cardio machines. 35% stay in the gym more than 30 minutes. Of those who stay more than 30 minutes, 70% start on the cardio machines. Show your work. Okay, so if a random person at the gym is observed, what is the probability that the person will start on the cardio machines and stay more than 30 minutes? Okay, and I apologize, the grammar should have a question mark and not a dot, but that's okay. Hopefully that wasn't the issue. So let me go down to the question. And what I kind of showed you last time is what's the first step is a good idea to do when you have a big, long word problem like this? Do you remember the first thing we do? You remember? Before you even look at part A and B. Probability of each event, but more importantly, we take these numbers that are given, the 60%, the 35%, and the 70%, and we write those as probabilities. I don't know if you remember, but I did that when I did a similar example a couple days ago. So 60% come in starting the cardio machines. What's the probability of that? That's just cardio. And how about C for cardio? And 60% is 0.6. 35% stay at the gym more than 30 minutes. So let's call that M for more equals 0.35. 70%, okay, so of those who stay more than 30 minutes, 70% start on the cardio machines. What's that the probability of? So how do we write that in symbols? And that's the key to these problems, is get the symbols right.
It's the probability of A and of C and M.
Okay, it's not an and. It's not an and. Actually, and will be the part A. Because it's what we're doing is we're restricting. We're only looking at the ones staying more than 30 minutes. That means we're given that we're in that group of 30 minutes or longer, stayers. So that's going to be cardio. That's going to be cardio given more. And that's going to be equal to 0.7. Anyone lost on these three pieces? That's usually the hardest part of the whole thing, is to come up with taking the words and turning them into symbols. Any questions on how I came up with the three symbols, three sets of symbols? Any questions? Okay, so now part A, if a random person at a gym is observed, what is the probability that the person will start on the cardio machines and will stay more than 30 minutes? What is that in symbols?
C and M. Probability of C and M.
Yeah, that's going to be C and M. And we had a formula that says the probability of C and M is the probability of C given M times the probability of M. The way I wrote it 2 days ago was the probability of A and B is the probability of A given B times the probability of B. But the letters don't matter as long as you keep track of them. And the good news is we have these. That's 0.7, let's write in parentheses, times probability of M is 0.35. And I did give you this calculator in case you need it. This is one of those where, let's see if it's in there. It might not be. Oh yeah, you can pick any of these. It doesn't matter. I don't know, throw normal probability, who cares? And just go to scientific calculator, and then you can type in what you need. And that is 0.7 times 0.35, 0.7 times 0.35, and you get 0.245. Any questions on part A? Okay, for part B, if a person starts on the cardio machine, what's the probability the person will stay longer than 30 minutes? Okay, let's get symbols. What's that the probability of?
Probability of M given C.
Exactly, M given C. And we had a formula for that. When you have a given problem, probability of M given C is the probability of M and C divided by the probability of C. Any questions so far? Okay. And note the probability of M and C is the same as the probability of C and M. Everyone agree with that? That and, it doesn't matter which is first for the and. For given it does, but not for and. So that's just 0.245 divided by probability of C was 0.6. Any questions on that? And again, you can always go to 0.2245 divided by 0.6. And you get 0.408 and a bunch of threes. Any questions at all on these four problems, these four questions? This is one of those where if you know how to do it, actually doesn't take very much time at all. But knowing how to do it is really hard for a lot of people. Okay, there's nothing here that we didn't talk about 2 days ago, but that doesn't mean it was easy. My guess is you're in agreement, maybe not. Maybe I'll look at your quizzes and everyone got 100%.
I have a question.
Yeah.
Is this type of like problems on the homework?
There's some that's on the assignments more, but definitely on the exams, you should look for these. They could be on the exams, and the exams are where the bigger points are. But there are some on the homework, the assignments. Okay. I don't know if that answers your question, but you definitely need to know how to do these. And remember, the quizzes are not worth much in terms of points for the course. They're worth a lot in terms of learning to get ready for the exams. Does that make sense? So they make sure that you pay attention to the quizzes. Try to do them. If you can't do them, then make sure that you watch my solution and ask questions on it if you don't understand my solution, so that you truly can understand, and then practice more. Okay, we did one 2 days ago. We're going to do another one probably if we have time today. Any more questions about this quiz? Okay, and just a note, the reason why I ask you, yeah, sir, question?
Did you hear me? I'm sorry, you kind of cut out.
I just heard, that's all I heard.
Okay, I had a question, but it's not about the quiz.
We'll get that in a minute. As soon as I share the next screen, then we'll go to the other questions.
Okay.
But I just want to make sure we're ready to leave the quiz. Any questions on the quiz? Okay, there's no questions on the quiz. Let's go to our lecture notes, or whatever you want to call it. And now it's time for your question on other things.
Okay, so last lecture, I missed probably the last 20 minutes, and then I went to look at the video, and it stopped recording once we took the break.
Really? Didn't work?
Yeah, once we that's the part I needed the most, was when we came back from the break.
Sorry about that. It was supposed to be recording. It said it was recording. I don't rewatch the whole video. I apologize for that, but it's a couple hours. So I'll make sure that I don't pause, because I hit pause and then restart and it said it's recording. You probably all heard it say it was recording, those who were there. So I apologize if it didn't work. Technology is weird sometimes.
Okay, do you remember what you were talking about? I know that it was about dice. I think the probability, I
think I gave more examples.
Yeah, because I was really lost on this quiz, and I was watching the video before class, and then I saw that it stopped when we went to break.
Yeah, my memory's pretty good, but I don't remember exactly what we did. But I do know we did another example or two. And but we'll do more examples today. And that might help you.
Okay.
And what I'll make sure of, because I guess Zoom doesn't work, I won't pause the video when we take a break, because I've learned my lesson. I'm kind of new to the taking break things, because usually I've been doing online classes that don't last this long. So I didn't take breaks. So sorry if it didn't record after the break. So I'll make sure I don't pause during the break. It just means that you're going to have to sit there and, fast forward for about 10 minutes for the future. So sorry about that. Okay. Any other questions? Okay. And again, I'm pretty good with technology, but if you're good with technology, then you also know that things happen. I didn't mean it, I promise. But stuff happens, and that one happened. Fortunately, we haven't lost internet yet. I got a little worried because there's a Spectrum truck near my house. I'm like, oh shoot, they might be closing it, but they didn't so far. Okay, any other questions? Okay, if there's no questions, what I'm going to do is we're going to talk about contingency tables. And really, those are best done with examples. So let's do an example with contingency tables. Okay, so here's the example. And what it says is a study was done asking students if they would rather have had their courses offered face-to-face, hybrid, or online this term, and also asking them what their work situation was: full-time, part-time, not employed. The table below shows the results of the study. So this table is called a contingency table. And what that means is that there's two survey questions, right? And in this case, the survey questions are, how would you like your course offered? And the second survey question is, what's your employment situation? So when there's two survey questions, then what these numbers mean, for example, this 55, these are tallies. So that means there were 55 students who work full-time and would prefer online class. Does that make sense? Any questions on how to read a table like this? Okay, there's nothing fancy, but they happen a lot. They're called contingency tables. And you've probably seen them before, but they come up in chapter 3 and in probability. So let's play around with it. So then there are some questions, a whole bunch, and I'll do these one at a time. So the first is, what is the probability that a randomly selected student prefers online classes and works part-time? Any questions on the question before I work it out? Any questions? Okay, so again, very important is to remember the definition of probability. And what is the definition of probability? What do you always have? Starts with an F. So what do you always have that starts with an F when you're talking probabilities?
Fraction?
Yeah, we have a fraction. Okay, so that's the first thing. We want the probability of online, I'll just call that O, and part-time. Let's call that P for part-time. P is not the best letter, but I'll use it. And the idea is that's always going to be a fraction. So let's make a fraction out of this. Okay, what is the numerator going to be? There's very little work to do, but you have to understand it. So what's the numerator going to be? Because we want online and part-time. So what will the numerator be? Looking for a number.
54.
54. Because there are 54 students who said that they are working part-time and taking an online class, or preferring the online situation. How do we get the denominator? That's going to be harder. So how do we do it?
Add all of them together.
Yeah, we add all of them together. And what I'm going to do, and I don't know if you noticed, But notice that there's a blank row and a blank column at the ends. That wasn't an accident. I'm going to put total. And total. So let's get the totals. So 12 plus 62 is 74. 74 plus 49 is 123. Okay, and let's add these three up. 777 is 21. 1, carry the 2. 10, 12, 15. So that's 151. And let's add these guys up. We get 109, and then 18 is 127. You're welcome to use a calculator, by the way. Okay. Now let's add across. And 12 plus 27 is 39. 39 plus 55 is what, 93? Wait, sorry. 94. And then 149 plus 54 is 203. 49 plus 37 is 86. And 18 is 104. Okay. And then we want the grand total. And the grand total, you add up either the row or the last row or the last column. You should get the same answer. So let's see. So 203 and 94 is 297 plus 104 is 401. And just to make sure I did it right, because I did it all in my head, 123 and 151 is 274. So then 374, 394, and 7 is 401. Good. So I'm pretty confident I got them right. Let's make that in bold, because that's an important number. Any questions on this? Again, you can use a calculator. That's always okay. I'll always embed a calculator in the questions. And if it's for homework, you can just use whatever calculator you like, Google or something, for addition. So what goes under the 54?
401.
401. And that's it. Any questions? Any questions on part A? Okay, let's do part B. So part B is, what is the probability that a randomly selected student prefers hybrid? So that's going to be the probability. Let's call it H for hybrid. And again, it's going to be a fraction. And we want the probability that the student prefers hybrid. All right. What's the denominator, by the way? Because that's the easy one in this case, now that we've done the work.
401.
401. Because we're not restricting the population at all. What's the numerator? Also easy because we've done all the work.
151.
151, because there are 151 students who preferred hybrid. Any questions on part B? Any questions? So I want to warn you, watching is easier than doing. Do you agree? Was my warning correct for the quiz, by the way, versus watching me do it 2 days ago?
Yeah.
Yeah. So practice, practice, practice. The quiz is more practice. All this stuff is practice. And then the exam is not practice. The exam is showing that you actually practiced a lot and you learned how to do it. Okay. Any questions so far? Okay, let's do part C. What is the probability that a randomly selected full-time working student prefers online classes? All right, let's do symbols first. That's the probability of what? So what's that the probability of?
online given working full-time?
Yeah, so that's a given, because remember that we're looking at only full-time working students. We already are told they're a full-time working student, and now we're asked to see, did we end up getting lucky and finding one that prefers online? So it's going to be online, or O, given full-time. Let's call it F for full-time. Any questions on that?
Yeah. So for the very first one, A, what
Mhm.
makes this one different than why is this one and the other one's the given?
Okay, so part A, what is the probability that a randomly selected student? So we're just looking at a randomly selected student. We're not told anything about the student other than they're a student. And then after the verb prefers, then online and working part-time. Do you see the and?
Oh, yeah, I see the and. Okay, thank you.
Whereas part C is probability that a randomly selected full-time student. So now we're told they're a full-time. We're not seeing if we get lucky and get a full-timer. Do you see that?
Yeah. Okay.
Okay. And again, that's how all these are. These are really easy if you know what to do, right? How much work did I put into this other than I had to do the addition? But once you do the addition, do you agree that getting these fractions, if you know what to do, is like takes 2 seconds, but you have to know what to do. So now we're looking at only full-time students, and we want to find out what is the probability of preferring online. So now we're going to have a numerator and a denominator. So let me go new equation and make a fraction out of it. Okay, so now we got to think about how do we come up with the probability of being online given full time. So I know you probably can't see the top and bottom, but I want to make sure that you can at least see the chart. So if we're given that they're full time, what does that mean that the total number of students are that we could choose from?
94.
There's 94. So notice what that means when we're given full time. It means we're just looking at that row of full timers, and everything else we ignore. We can kind of really look at this as a much simpler problem. Ignore all the other stuff, and we could say the total is 94. How many preferred online of these 94?
55.
55. So the answer is 55 over 94. And let me make it bigger because it's way too small. And let's do this. There we go. That way it'll show up. Any questions at all on part C? Do you agree that if you know what to do, it's really easy, but if you don't, you'll get it wrong? Sound about right? Okay, the next one is, what is the probability that a randomly selected student works full time or prefers a face-to-face class? So that's going to be probability of full time, call that F, and then I'm going to write down the word or. And then I need a letter for face-to-face. How about F2F? Since we've already used F for full time. Any question? I'm going to boldface or. That's like the new thing for this problem. Any questions at all on at least writing down what the probability is this time? Writing down in symbols. Okay, now comes a very important formula, and that is the following. And I'm going to put it below, and that is the probability in general, A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this is a key formula. I'm going to put that in red because it's so important. Happens a lot. And the reason why this works is for either A or B happen. Well, if we add all the things that happened from A to all the possibilities for B, then it sounds like, A or B, except that we might have double counted. So if it's in both A and B, we've double counted in the first term and the second term. So that's why you got to subtract the double counters. And the probability of A and B is the double counts. Any questions at all on this idea? So we just do it. That's the probability of F plus the probability of F to F, face to face, minus the probability of F and F to F. Any questions on using the big formula? Okay, so now I just do one at a time. And let's go new equation, make a fraction because probabilities are fractions. And probability of F full time. Well, there's how many full timers? How many were full time?
94.
94. Out of how many total?
401.
401. So let me write down 94 over 401. And that's way too small. Okay, so that's the first one. And I want to note that unlike part C, there's no givens. Okay, we're not restricting the population to any of these in part D. So that means the denominator is always going to be 401. And in fact, I can do a little math. And if the denominator is always the same, I can put them all together. Everyone okay with that? That's how you add fractions when the denominator is the same. You just add the numerators. So then I go to the probability of face-to-face. What's the probability of being face-to-face? So what's the probability of face-to-face?
123 over 401.
Yeah, 123 over 401. So that's going to be 123. And notice by putting it up on top, it's still over 401. And then I go minus, and then the probability of F and full-time and face-to-face. Okay, what's the probability of full-time and face-to-face?
-12 over 401.
Yeah, 12 over 401. Any questions on that idea? So 12 over 401. And again, I put the 12 on the top, and then everything's over 401, so I'm good. And now let's just do that subtraction. Because it just wants to be done. So notice 94 minus 12 is 82. 123 plus 82 is 205 over 401. Any questions? Any questions on the process on part D? Why is it negative 12? So right here, it's a minus. It's minus probability of face-to-face and full-time, or full-time and face-to-face. That's from the formula that I gave you right here. You basically are subtracting the double counts. So that comes from the formula. And if we look at face-to-face and full-time, that's this number 12 means that they're both full-time and face-to-face. So I have to go minus 12. Does that make sense? Do you understand how that minus 12 happened now? So that minus 12 comes from the minus full-time and face-to-face. So we definitely have a minus there. There's a minus, and there were 12 that were full-time and face-to-face. Good, good. Okay, any other questions? Okay, and again, I'm going to give you that big warning that I gave you last time. It's much easier to watch than to do. So my suggestion is have a piece of paper and pencil out and try to write down the answer before I write it down. Okay, and then take a look, see if you got what I wrote. And the hope is you do. And if not, and you don't understand, then it's time to ask questions. All right. So now, part E. If 5 of these students are randomly selected, what is the probability that at least one of them will be employed? Okay. How do we do that? Any suggestions?
You add everybody that works part-time and full-time together.
You could do that, but that's actually harder than another way. That's the hard way. We can use what's called the rule of complements. So let me write this down. And the rule of complements is something I'm sure you already know, or you just don't know the words of it. If I told you that 94% of the Tahoe electorate who voted for me, could you tell me how many didn't vote for me? In my last election? So if 94% in my last election voted for me, it was a lot of years ago, what percent did not vote for me?
6%.
6%. Okay, and you got that, hopefully, by taking 100% minus 94%. That's how you got that, right? And that's the rule of complements. So it's the probability of not A is equal to 1 minus the probability of A. And 1 is the same as 100%, right? So it's a really important and useful formula. We're going to use it a lot. Any questions on the rule of complements? Okay, again, it's something that my guess is you already know, but you have to think to use it. Okay, and the reason I'm going to use it is now it's a whole lot easier to come up with the answer to this question, because the problem with at least one of them will be employed is that means 1 or 2 or 3 or 4 or 5 of them will be employed. Does that make sense? All right, so it's a lot easier to use the rule of complements. What is the complement? What does it mean to say not at least one of them will be employed? How many are employed if not at least one is employed? So what does that mean to say not at least one is employed? What's the complement of at least one? Any ideas? Maybe I'll do it this way. I can show you this, by the way. By the way, do you think I'm a 200 billion millionaire now?
No.
No, I'm not. Okay, so I didn't win. But it's even worse than that. I did not have at least one of my 3 guesses to get the mega number right. So if I did not have at least one of the mega numbers right, how many mega numbers did I have right? So if I didn't have at least one, how many did I have right? I had 0 right. Okay, which is the truth, by the way. This ticket was really bad. Okay, it wasn't just that. I got like, I think nothing right. Okay, so the idea is not at least one employed means none employed. Any questions so far? All right, so now I got to find out the probability that none of them of these 5 are employed. Well, let's talk about just the first one. What's the probability that the first one is not employed? What's the probability the first one's not employed? And that's supposed to be pretty easy.
9 over 401. I mean, sorry, 123 over 401.
123 would be not liking face to face.
104 over 401.
104 over 401, because the not employed total is 104.
Oh, okay.
Do you see that?
Yeah. I was just getting confused.
Yeah, this is hard. So I can write down 104 over 401. It's kind of I didn't plan on this, but kind of interesting numbers. They just switch them. That's just a total coincidence, by the way. All right, that's the first one, though. But not only the first one, but all of them, all 5 of them have to be not employed. Well, what's the probability that the first one is not employed, that the second one is also not employed? How many left are there to be not
103.
Not employed? 103 over what?
400.
400. Because we've taken that one non-employed person out. How about the third one?
102 over 399.
Yep. 102 over 399. How about the fourth one?
101 over 398.
Yep. 101 over 398. And then finally, we had 5 of them. So the fifth one, hopefully you get the idea now. 100 over 397. Any questions at all on coming up with this? And I'm going to spare you the pain of watching me plug it into a calculator, but it can be done. You just type it all out. Any questions at all on part E?
Could we have used this method for the question on the first question of the quiz?
The first question on the quiz, it's a little more complicated than that.
Because of like the 5, whatever.
Yeah, it has to. It's messier. You really got to do combinations.
Okay.
It's not quite as easy as it sounds. I could go over the math, but I'd rather not, because I think like most of you would log out. So let's not do that. Instead, just use the calculator. It's a whole lot easier. Okay, so F is our preferring online classes and working part-time mutually exclusive. All right, so first thing, we need a definition. I don't expect you to be able to answer this until you know what mutually exclusive means. So let me write down a definition. events A and B are mutually exclusive. If the probability of A and B is equal to 0. So let's put that in red because it's really important. Okay, so if the probability of A and B equals 0, then we call them mutually exclusive. What could you say if the probability equals 0? What does that tell you? Just in words?
It's not going to happen.
Yeah, it's impossible. Okay, it's impossible for both of them to happen. Okay, so let's find out if preferring an online class and working part-time is mutually exclusive. Well, we're going to do probability of O and how about PT for part-time? What's the probability of O and PT? Let me make a fraction. And we're not ready to answer until we can see the table again. So probability of liking online and working part-time. What is that probability?
54 over 401.
Yep, 54 over 401. Is that equal 0?
No,
No, that's definitely not 0, right? And in fact, when is a fraction 0?
never.
Not never.
Well, 0 over 0.
0 over 0 is just bad. That's not even a fraction. That's just bad.
0 over any number.
Yeah, 0 over anything but 0, actually.
Yeah.
Okay, so a fraction is equal to 0 only when the numerator is 0. So therefore, they are not mutually exclusive. Any questions on this idea? Okay, then the last question is, are preferring a hybrid class and not being employed independent? Okay, and just like the last one, that needs a definition. This one's a lot more complex. It's 2 events, A and B, are independent if any of the 3 of the following are true. So the first one is the probability of A and B is equal to the probability of A times the probability of B. The second is the probability of A given B is equal to the probability of A. So note the second one says that if you're told that B happened, and then you want to find out what is the probability that A happened, that's no different than just not being told that B happened. So B helped nothing in determining whether A happens. And then part C, the third one, is basically the same with A and B switched. So probability of B given A equals the probability of B. So let me make those in red. It's a definition. It's an important one. And let's put independent in red. Okay, and there's a definition. And then just a note, otherwise, A and B are dependent, which is the opposite of independent. Any questions on this big definition? Okay, just note that they're independent if any of those three are true. So the one you should pick to decide is the easiest. And every problem is a little different. Sometimes it's easier, sometimes it's harder. Okay. I do want to note that if you don't know anything else, part A is the hardest because part A has 3 probabilities in the equation. Whereas part B and part C, they only have 2 probabilities. Do you see that? So if you're not already given some of these guys, if you're not already given A and B, then B and C, those are the easier ones. So now we're able to answer part G. So let's find the probability of A given B. So that means the probability of preferring hybrid, that's H, given not being employed. Let's call that NE for not employed. And let's find that probability. It's a fraction. So we got to find the probability of preferring hybrid given not employed. So what's the probability of preferring hybrid given not employed? What's the numerator? And here's a hint. We're given not employed. So what is that probability of preferring hybrid given not employed?
$104.
Okay, 104. Remember, a probability is a fraction. I'm needing 2 numbers here. Yeah, 37 over 104. Any questions on that? Because in these not employed, there's 37 that prefer hybrid out of the 104 not employed. So 37 over 104. Oops. And let's find out the probability of preferring hybrid. Okay, so let's get a fraction out of it. Okay, so let's go back, find the probability of preferring hybrid. What's that going to be? Probability of preferring hybrid is so what's the probability that hybrid is preferred? Are your brains tired? So it's a fraction. What's the numerator? What's the denominator? Can you hear me? Everyone got silent, so. So I'm going to give you, I want at least some, I don't know, or I need help, or I got it.
I don't know.
Okay, so We're just looking at the probability of preferring hybrid. How many preferred hybrid
151.
out of how many total?
401.
And that's the fraction. 151 over 401. Okay. Did I make it easy once you see it? 151 over 401. There's no given, so the total is what we divide by. So 151 over 401. What's the easiest way of telling if two fractions are the same? Given that you have a calculator.
Just calculate it, then divide.
Yeah, put them in decimal form. So 37 over 104. So I'm going to let Google do the work. 37 over 104 is 0.3558 or so. And 151 over 401 is 0.3766. Are those equal?
No.
No. Since they're not equal, they are, let me write instead of they, how about preferring hybrid and not being employed are dependent. Any questions? Any questions on this?
What exactly does it mean again to be independent? Like
Okay,
I know those are equal, but like what does it mean?
So what is it? What does it mean? Not mathematically, but what does it mean as an idea? Is what you want to know.
Yeah.
Okay, so what it really means is that if somebody told you that they preferred a hybrid class, you have information that is useful for determining the chance of them not being employed. Whereas if they're independent and someone told you that they preferred a hybrid class, that doesn't help at all in deciding if they're not employed. So let me give you some examples. Let me give you some examples that you can understand. Okay. Let's suppose that event A was the score of the last baseball game that the San Francisco Giants played. Okay. So, and let's suppose event B was the high temperature in Tokyo, Japan. Do you think those are dependent or independent?
Independent.
They're independent. Because if someone told you what the score was in the last San Francisco Giants game, that's not going to help you at all on deciding what the high temperature in Tokyo, Japan is. Do you agree?
Mm-hmm.
Those would be totally independent events. Okay. On the other hand, let's suppose A is the event that somebody gets a bachelor's degree in engineering, and B be the event that somebody makes more than $50,000 a year. Do you think they'll be dependent or independent?
Dependent.
Dependent, because if someone says they got a bachelor's degree in engineering, then there's a much higher chance that they make more than $60,000 a year. Does that make sense?
Yeah. So
that's in general, but the math is this equation or these equations.
Yeah.
And this given is what we just did, what we looked at. Yeah, sorry.
Well, like the example with the independent events,
Mm-hmm.
like for the example you gave with the weather and the baseball, those probabilities, now going back to the actual statistics, like the numbers, those probabilities would be equal.
It's not the probability of the
Probability.
San Francisco winning and
It's
it
the
being say 5
probability
to 7.
given that, or whatever, like the probability of A given B.
Right. So if you're told that the Giants won the last baseball game, then you don't have a higher probability that tomorrow it's going to be warm in Tokyo.
Oh, okay.
You see that?
Yeah.
That's why the given is there. That little vertical line segment is a given.
Okay.
Does that help understanding what's going on?
Yeah.
Okay. And it's really important. So for example, it helps you in your survey design. So if for example, race and your survey question are independent, then it makes no sense to stratify by race because you don't need to. There's no bias if you asked all the same race. Does that make sense?
Yeah.
But if they're dependent, stratifying by race makes a lot of sense.
So
Is
do
it
you look
clear?
for ones that are dependent and then stratify based on whatever kind of group that is?
Yeah, you stratify by what you believe is probably has a dependency relationship.
Okay.
Do you see how that works? So that's one use of it. There's lots of uses of it, but that's one of them. Okay, any other questions on this? Okay, I've been going a long time and I'm going to let you take a break, but what I'm not going to do is I'm not going to turn the recording off because that was a disaster last time. I learned my lesson. So just note, if you watch this later, you're going to see 5 minutes. I'm going to go 5 minutes of break because we're going to kind of, I don't know about break, but you're going to like talk to each other towards the end, the last half hour or so. So come back at 5:08. And so sorry if you're watching this recorded and you're going to hear silence for 5 minutes, but that's the way it's going to be. Okay, let's come back. I see 50, 508, 509-ish. And at least you got a little break. But we'll have time. You'll see at the end where you're going to be talking to each other. It's going to feel like a break almost. So let's go back, and I'm going to do one more example before we get into the project. So let's pop on my desktop. Okay, so here's the next example. And that is you will roll 2 6-sided dice. So here's a die. And you're going to roll 2 of them. And the question is, let A be the event that the first die lands in a 4. So that would be one of these guys. B be the event the first die lands in an odd number. That's 1, 3, or 5. C be the event that the sum of the dice is 11. And D be the event that the sum of the dice is a 7. All right, so the first question is, which of the following are mutually exclusive? A and B, A and C, A and D. So see if you can tell me which are mutually exclusive. Take a look at the choices and look at the definitions. And give you a minute or two to read it and see which one, kind of one at a time. Look at A and B, then look at A and C, then look at A and D. And see which of the following are mutually exclusive. It's either going to be none, 1, 2, or all of them. So what do you think? So I'll give you a minute or so to kind of think about this. It's pretty easy, actually, if you understand mutually exclusive. So let me know when you come up with your idea.
Should we write it in the chat?
Chat's good? But hopefully all of you are trying. That's the idea, is I want this to be interactive. That's the whole point of these. You know, this isn't just some video to watch. Okay. So at least a couple of you should try telling me the list of the ones that are mutually exclusive. It might just be nothing. It could be, I don't know, one of them. It could be a couple of them. Okay, let's take a look. So let's look at it one at a time. So A and B. So let's look at these. And we want to see what is the probability of A and B. Well, A means that the first die is a 4. B is the event the first die is odd. What is the probability of A and B? What is that probability?
0.
It's 0. You can't, if it lands in a 4, it's not odd because 4 is not an odd number. So that means I'm going to write ME for mutually exclusive. Okay, let's look at A and C. What's the probability of A and C? So A is the event, the first is a 4. C is the event, the sum is an 11. What's that probability?
Zero.
0, because the first is a 4, then the second would have to be a 7, but there is no 7 on a die. So that is 0. So also mutually exclusive. So far, those two are. Now let's look at A and D. Probability of A and D. So now the first lands at a 4, and the sum is a 7. What is that probability? Okay, and the idea is if the first is a 4 and the sum's a 7, can you tell me what the second one is? It's not a trick question. It's supposed to be easy.
Oh, so 3.
Yeah, so it's going to be 3 divided by, and how many different 2 die rolls are there? Were 36. And that's not 0. So not mutually exclusive. Any questions on part A? Okay, part B is which of the following are independent events? A and B, A and D, B and D. So what I want you to do is work on A and B first and give me a yes or a no. Give you a minute or so, shouldn't take too long. Tell me if those are independent or are they dependent? Okay, so I'm hoping for 2 people deciding, at least, or all of you would be even better, but it'd be nice if at least a couple of you. So the question, are A and B independent? Okay, so we got a yes and a no, so let's find out. Okay, so let's take a look. Well, we can look at the probability of A given B. What is the probability that the first die is a 4 if you're told that the first die was an odd number?
0.
0. What's the probability of A? What's the probability the first die is a 4?
4/36.
Not 4/36. It's just the first die. You don't have to worry about the second die.
Oh, okay.
How many 4s are there on this first die?
1/6.
Yeah, there's just one. It's just 1/6. Is 0 equals 1/6?
No.
No, they are not equal to. So they are not independent. Or in other words, they're dependent. Any questions on that? Okay, let's look at A and D. So A again is the event that the die lands on a 4. D is that the sum is a 7. And decide whether those are independent or dependent. Again, it takes some calculation. So independent or dependent for this. And I see one guess or one try. Let's see if we can get at least a second person trying. All right, if not, because I need to get to it, let's look at it. Probability. It turns out that D given A is easier than A given D. It's a lot easier to say, what is the probability you get a 7 knowing the first was a 4, than to say, if the sum is a 7, what's the probability that the first was a 4? So probability of D given A is equal to, well, if we're given the first is a 4, then we're only looking at the second die. And if the second die is a 3, then you got your 7. Nothing else will get you a 7. There's only one way of that happening. That's for the second die to be a 3. And there's 6 items on the second die, faces. So that's 1/6. The probability of D, well, now we're looking at all the different sums of 7. You can get a 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, or 6, 1. So there's 6 different ways of rolling a 7. And there are 36 different 2 die rolls. Is 1/6 and 6/36 the same?
Yes. So they're independent.
They are equal. So they are dependent. They are
Independent?
Yeah, did I write it wrong? Not equal, say, or not? Yes, they are independent. There we go. Any questions on this idea? Okay. Hopefully you get the idea. Again, I want to get to the project, so I'm not going to do the rest. I had a whole lot just in case. I always have more ready just in case I need. But all the ideas are here in terms of independent, dependent, mutually exclusive, and just general probabilities and contingency tables. So what I want to talk about now is the project. So the first thing is, let's go to the project. And if I hit the syllabus or home, either way. So first thing to note is the project is due April 27th. So you have some time left, but not forever. Okay, it's another what? It's the 15th today. It's another 12 days. So it's enough time, but not if you wait 11 days. It won't be enough time. And for project 1, you're going to collect quantitative data, and you can use the computer to display each of the charts discussed in the class and also the statistics. Let me click project 1. Okay, so here's what you have to do, and I'm going to summarize this and talk about some details. The first thing is you need partners. And again, if you don't have a partner, or if you only have 2 in your group, I know that one of you already is looking for another person. Hopefully you already found someone, but make sure that you have partners. And this you should do right now as I'm talking. You can put in the chat box and get some partners out of that. You need to have a partner. Okay, and 3 is better than 2, by the way. 3 in your group is better than 2. Okay, then you're gonna come up with a survey question, something that you're interested in that you're going to study. Okay, you need to think about who might hire you to do this study. That doesn't mean you have to get paid. Okay, of course, if you get paid, that's great, but you don't need to get paid. But at least theoretically, if nobody's interested in this study, then it's worthless and it's not a good project one idea. Okay, so come up with your what I call the client. Okay, it needs to be quantitative. Then what you're going to do is you're going to think about how are you going to come up with a sample so that you can at least somewhat reduce bias. And the requirements is either you can use simple random sampling, which I warn you is pretty much always impossible. So that's why I didn't even highlight it. Or you can use stratified sampling or cluster sampling. So just about all of you are going to use stratified or cluster sampling. Okay, because we're in times of COVID, most of you will probably do this as an online survey. The only reason why you could do this as an in-person survey would be if it had to do with your work and you're communicating with people in your work anyway. So that might be, for example, if you're a nurse and you work in a hospital, you can, look at data from patients. If you're I don't know what, in the wait staff in a restaurant, then you can look at data from the people buying stuff in your restaurant. Or if you're working in some kind of store, you can talk about those people because you might see people. But most of you will do this as an online thing. Okay, you'll email and stuff like that. Any questions so far? Okay. In your project, you're going to discuss a bias that might have occurred due to the way you conducted your sample. If you think there's no bias, you're wrong. It's like not possible to have no bias. So just note. Okay, I'm not going to read every word of this because this is all from the syllabus. You can click on it and read it. But here's a biggie. Sample size must be greater than 30. By the way, what's the smallest number greater than 30 for a sample size?
31.
31. So don't do a sample of 30 because that's not big enough. 31's okay. You don't need to have 1,000 because that just takes a lot of work, but you have to have more than 30. So most people do somewhere between 31 and 40. Okay, because that's similar. But there's no reason to, ask a couple hundred people. So it's going to be a survey of people, and it takes too much effort to ask more. So if there's 3 in your group, by the way, it's 11 people each. That's not so hard. Okay. Then once you have decided on your survey question, who your client is, what is the population, and what your sampling technique is going to be, then you go and conduct the study. Okay, it shouldn't take that long to conduct the study. If it does, then your project's probably too hard, and try something easier. Okay, so you're going to conduct the study, and you're going to get your data, and you're going to have a data set of, a little over 30 values. Okay, and just a note, if you're doing stratified sampling or cluster sampling, it's just one data set, even though you've split it into different groups. In the end, that's just to get unbiased data. But there's just going to be one column of data that you use. Okay, then the next step, I'll show you. Is you're going to put it into the spreadsheet. And your data will go here. So you erase whatever's in there and then put your data in. But to do that, you always have to go to File, make a copy, give it a name, and then hit OK. And then you'll be able to enter your data. Otherwise, you can't. Just let you know that. So you enter your data into the spreadsheet. Okay. And just in case you want, it's also on Canvas. But I figure since we're here, let's look at it. View. I put it in the chat box. And so then you've got it, but it's also again on Canvas. And notice that once you put these in, it gives you the main statistics. So what you're going to do, by the way, into your project, you're going to basically take these guys up to Q1. You're going to copy it. You're going to paste it into your document. If that sends not to work, then you can always use like a snipping tools, but usually copy and paste works. Okay. You're also going to look at a histogram. You're going to look at a box plot and a stem and leaf plot. Okay. If there's other plots that you find valuable, you can look at those too, but these 3 you have to do. Any questions so far? Here. Okay, then once you have your data, your charts, and your statistics, then you are going to interpret all of them. And I want to make a big point that a lot of people just don't do, and I'm not sure why. The whole purpose of this project is to make recommendations to your client. So what you're going to do is you are going to say, the first quartile was 3.8. So because of that, here's a decision the client might make for the client's business or whatever the client is doing. And you're going to do that for every one of the statistics and for each of the charts. Any questions on that idea? Okay. The most important of all of the statistics is the standard deviation. And the standard deviation has all kinds of things that come with it. So z-scores, for example, uses a standard deviation. So does the empirical rule and Chevyshev's theorem. You can find those in the book and also in the chapter video to hear about those, and those need to be in the project. And just the standard deviation by itself. So you want a full paragraph just on the standard deviation. And based on the standard deviation, how is the client going to react? What kind of decisions might the client make after understanding the standard deviation? Any questions on that? Okay. This is a paper, so there should be an introduction, a body, and a conclusion, just like any old paper. And you should conclude by making the main recommendations. That's important, okay, that you're going to give based on all this stuff. And also how you might make this project better if you had more time and you could ask more survey questions and maybe do a different type of sampling so that you don't have as much bias. How could you reduce that bias that you identified? Okay, that is the main piece of the project. If you have a rough draft a few days before, so again, this project is due on, where was it? Back. So the project was due on the 27th of April. The 27th of April is 12 days from now. That is a week from Tuesday. And if you can have a draft written by a week from today, I'll take a look at the draft. I'm going to spend the last bit of time during our class, and I can help you with it. That's kind of my guarantee. So if you have that draft ready, I'll look at it during class, and then I'll give you suggestions. Otherwise, you got to cross your fingers and hope you do well. But again, you want to get this done early. So you want to get this started right away. Any questions at all about the process of the project and the timeline?
I did have a question.
Sure.
Are we collecting the data together? I know we're collecting the data together, but are we then writing the paper together, or is it separate?
That's a good question. And the idea, and here how it works, is that one of you submits the project in Canvas and make sure all three of your names are on it and everyone gets the same grade.
Okay, okay, perfect. So we do it on a Google Doc all together.
Yeah, Google Docs an easy way of doing it. I think Microsoft has something similar, but whatever works for you so that you're working on the project together.
Okay, awesome.
And there's one submission, there's one project for your group.
Okay.
It's the only part of this class where it's a group points, I guess, for the course. Okay, other questions? Okay, so what I want you to do, I know there was one request for a partner, and hopefully if there's only two of you, then please let the other person come in. Okay, because you must have, by the way, you must have partners. Okay, we've had weeks now. This is the end of week 2 already. So we've had weeks to find partners. So just a note, a 30% penalty will be incurred to any student who cannot work with another student. In other words, you cannot pass. You cannot get a passing grade, basically, on this project if you work alone. So partnership is required. Any questions at all? Okay, now I'm going to try something I've never tried before. So I hope it works. It's a technology thing. Well, first I'm going to unshare my desktop. And next, what I want to do is, let's hope this works. I'm going to stop recording because I'm done lecturing, talking about the project. So I'm going to stop the recording.